Hi, I'm at the Computing Conference 2025 in London, and joining me here is Aimal Khan from the Pforzheim University in Germany. Hi, Aimal.
Hi, thank you for having me here.
Nice to have you. So, Aimal, can you just walk us through your academic journey?
So I have been doing research in the area of AI and wireless communication for the last 1 decade, and mainly my research focuses on the application of AI in the area of sensorics, so how we can make sensors more and more smart.
That's very clear, thank you. And what is your current research at the moment?
My current research is on a specific type of sensors. They are called magnetostrictive position sensors. So these sensors are used in places where we need really accurate distance or velocity measurement. So I could say we need an accuracy up to micrometers, not millimeters, but micrometers. So for example, if you talk about the hydraulic presses, if you talk about the level sensing, then these type of sensors are used there. And they have an accuracy in the range of almost 10 micrometers.
All right. So what's the biggest problem your research solves? And why should everyone know about it?
Okay. So regarding this specific type of sensors, the magnetostrictive position sensors, they are really disturbed by external interferences. So for example, if I have a sensor here and if I turn on and off this light, for example, then this sensor is that much sensitive that it picks that energy from that light and it's disturbed by that energy. And then definitely we would have some anomaly or disturbances in the accuracy. So then my goal is to apply artificial intelligence so that we can mitigate the effects of these disturbances or the interferences, and we should have improved or the recoverable accuracy.
Right. And was there a moment during your research when something totally unexpected happened?
Yeah, it happens not once or twice, it happens a lot. You know, the issue with artificial intelligence is that the data sets which we have there are mainly acquired in a very customized laboratory setup. So we don't know a lot about the outside environment. And sometimes you train your model for something which is only inside laboratory, and if you go outside, then you see something which is really you have never seen before, or your trained model has not seen it before.
How do you overcome that?
Yeah, I mean, you cannot cope with all of these cases, but definitely we try to combine the practical scenarios and the laboratory. So we do the training inside the laboratory and as well as at some practical site where this sensor is going to be applied.
And what's one little known fact from your research that most people would find hard to believe?
Yeah, so the research which I'm doing, we have an inaccuracy of, let's say, 3 millimeters. And with my current research, we have reduced that inaccuracy to, let's say, 40-50 micrometers. So it is...
That's by a factor of, I can't even work that out.
Yeah, exactly, yeah. So that's really a huge step that we have improved the accuracy a lot by using really clever mechanisms combined with artificial intelligence.
Right. And how might your research make a difference in the real world?
I mean, as I said to you, we are still doing a lot of the things in the laboratory, and there are challenges like having these things being functional in a practical setup. But if we can solve this external interference mechanism, for example, so that's really a huge headache for the industries who are using these sensors. If we can solve this problem, then it's really a huge problem which has been for the last 3-4 decades. This problem is there, and if we can solve this would be a huge step forward.
Okay. And which sort of practical applications are you most excited about?
So I'm mostly excited about the practical applications in the level sensing, for example. So in level sensing in the industries, for example, if you have a tank, a huge tank, and this is some industrial environment, and we want to know what is the level of fluid inside a specific tank. And inside the industry, not only this tank is there, there are a lot of other sources of electromagnetic noise, So it would be really interesting to see this AI mechanism which we are developing in the industry and providing us better accuracy.
So is this your first time at the Computing Conference?
Yeah, of course, this is my first time, and it's really interesting.
Why, of course.
It's interesting, and I'm happy to be here. It was really wonderful, and I will try to be next time also here.
Nice to have you here. Thanks very much, Aimal. Thanks for your time and all your insights, and good luck with your presentation tomorrow.
Thank you so much for inviting me for the interview, and I'm really glad to be here, and it's really nice.